Yo.
Hi, I'm Abby. I'm 18 and I'm a Capricorn.
Hey, I'm Antonio. I think I'm a Gemini. Yeah, and I'm 17.
Hi, I'm Brooke. I'm 17. I'm a Gemini.
Hi, I'm Jonathan Shubin. I'm 18, and for our stats project, we decided to look at the degree to which certain demographic variables are predictive of average state income.
To collect our data, we looked at the most recent studies based on the 2010 census data. The variables we observed were median age, unemployment rate, high school grad rate, average number of kids per family, average funding per pupil in public schools, percentage of population registered to vote, and race demographics to predict the average income of the state.
We organized a table with the values for each variable by state. This allowed us to create a multiple regression ANOVA table analyzing the relationships between the variables.
The correlation coefficient value of 0.876 from our ANOVA table tells us that there is a strong positive correlation, meaning that there is a distinct relationship between the state average income and the 8 predictors.
For the coefficient of determination, we used adjusted R-squared because we studied more than one factor in our test. In the context of this problem, this means that 72% of the variation in state income is based on our predictor variables, and the remaining 27.88% is based on other factors not accounted for in our model.
The standard error represents how much the predicted average income for a state might deviate from the actual value of that state. In our model, this standard error is plus or minus $3,735.66 a year.
The significance F value represents the p-value for the entire equation, meaning that it determines whether or not the model is significant. Our value is 9.79 times 10 to the negative 11, far below the alpha value of 0.05, making our model statistically significant.
Our intercept is 48,346,000 per year, meaning that theoretically, if no one existed in a state, that would be the income. The variables of median age, unemployment rate, average number of kids per family, percent of African American residents, and percent of white residents are all negatively impacting the income of each state. The variables of high school graduation rate, average funding per pupil, and the percent of the population registered to vote are all positively impacting the average.
This model can predict how changes in the predictor variables in any state will affect the average state income. For example, if Alabama were to have an increase in children per family, this model would predict that their state income would decrease and tell you by how much. Another example is if Oregon were to increase funding per student, this model would predict that our state income would increase. This could help inform policy by understanding how various factors influence state economies.
The null hypothesis is rho equal to 0, and the H1 hypothesis is rho is not equal to 0. Because the significant F is less than alpha, which means there isn't enough evidence to reject H null, meaning there is a significant relationship between average income per state and all the other variables.
To put our data into perspective, we decided to test for the average income of Washington, D.C. We created a prediction model using the y-prime equation, placing the variables we found for D.C. within the coefficients found in the ANOVA table. Using this equation, we found that D.C.'s predicted income would be $66,542 a year, not far from its actual income of around $71,000 a year.
The study we found compared education spending across all 50 states. This connects to our study because as we compared education spending per pupil, we found a strong positive correlation between dollars spent and average income per state.
In our study, we found that Connecticut has the highest average state income and the 3rd highest spending per pupil. In contrast, Mississippi has the lowest average state income and the 4th lowest spending per pupil.
Although we tried to use consistent data, there could have been errors in our findings. Almost all of our variables were found through third-party studies that used mostly census data, so that could have created problems in our model. The data isn't all from the same year, and some of it isn't from the same source, so there's discrepancies in our samples.
This is important because our findings are applicable in many ways to the real world.
Our predictor variables clearly impacted the average state income, and having both negative and positive coefficients points to the complexity of income.
Our study also highlights the importance of public education.
Miss Wolford, Miss Webb, and Baymax.